All right, we've spent a lot of work on graphing parabolas, and now we are actually going to work on solving quadratic equations, okay? And specifically today, we will be looking at solving quadratic equations by square roots, and we'll do a little introduction and then a few solved examples. And to start things off, though, I want to be clear about some notation, okay? And you can see on the screen we have x squared equals 9, and we're contrasting that with just what the square root of 9 is. Okay, so when we have an x squared equals 9, we want to think about what x could be, right? And so what values could square to get a 9? And there are two of them. X could be 3 squared is 9. X could also be negative 3, because negative 3 squared is 9. And so we might say then that x equals plus or minus 3 as our solution there. All right. And then, but in contrast, though, there's a little bit of just math notation here. When mathematicians talk about just the square root of 9, that is equal to 3, okay? You wouldn't say that the square root of 9 is negative 3, okay? You would just say the square root of 9 is 3. And so we call that the principal square root. So I guess that means there's a secondary square root of 9 that's equal to negative 3. But the key point here is when we're talking about the square root of a number, we generally write the positive square root of that number. It's a little bit complicated and I think a little bit unfortunate, but if we are wanting to get both square roots, we could also talk about the negative square root of 9 is negative 3. Okay, so if you go to your calculator and you type in the square root of 9, you're just going to get a 3. You won't get the negative 3. Probably. Okay, so again, it's a little bit inconsistent and it's a little bit goofy and frustrating, but just keep that in mind, okay? So if we're looking for something that squares to get 9, we have two answers. If we're looking for what the square root of 9 is, we have just one answer, okay? All right, so let's do some examples of solving, and I'll try to clear up any confusion through some examples. So these are some particularly nicely set up quadratic equations where you can solve them with square roots. Basically what we're doing is peeling the onion, like I referred to way back in our initial units on solving linear equations. We're just working from the outside in. We're trying to isolate for x. And that method won't work in future quadratic equations. We'll have to do some more complex work. But here we can just basically do the same thing to both sides. So let's do it. So for this first one, we can subtract 6 from both sides. And I guess what I would want you to think about as we're going through these is what is unique about these particular quadratic equations that allows us to just do the same thing to both sides or just solve by square roots. 5x squared equals 45. We can divide by 5. We get an x squared equals 9. And hey, we just did that problem, right? So what we can do is we can square root both sides. But we need to remember to get both positive and negative square roots. Okay, so even though right here I'm just showing the positive square root, remember that there are two numbers that square to get 9. One's positive and one's negative. So x equals plus or minus 3. Okay, and if you just did the square root of 9 on your calculator, you would just get a 3. Okay, so I'm harping on this a lot because it's kind of confusing and I want to make sure you get it. Okay, so x equals plus or minus 3. Next example is this guy. And again, be thinking about what's unique about these equations that help us just solve them with square roots. Subtract 7 from both sides. So we have a negative 2x squared, 7's cancel. 5 minus 7 is negative 2. We can divide by negative 2. That's friendly, that's nice. And we get x squared equals 1, so square root both sides. And let's get the positive and negative square roots of 1, which are plus or minus 1. Okay, so there's our solution. Next one, it looks like it's in a different format, right? And so it's sort of looking like vertex form, kind of. Okay. Before we had standard form with b equal to 0. There's a clue that these are friendlier when b is equal to 0. But now we have a vertex form equation, and we can. Here's what you don't want to do. You don't want to multiply x minus 2 by x minus 2 and then distribute the 3 and then try to solve. Okay. We already have it in vertex form, so let me be super clear. You don't want to do this. X squared minus 4x plus 4 equals 75. I'm actually going to go through this process to demonstrate something for you right here. Distribute the 3, and then what do you do, right? We could, I don't know, maybe subtract 12 from both sides. 63. But then it gets hard, right? How do you isolate for x? This is hard because we have two x's. One is an x squared term and one's an x term. And so then what do you do to isolate for those x's? How do you combine them together? And so we'll spend a ton of work on resolving that dilemma, but we're not going to resolve that right now. We are going to follow a different strategy. We can just divide both sides by 3, okay? And so we get an x minus 2 quantity squared equals 25. Now we can square root both sides. Okay, and now it's going to be we have to be a little bit careful with keeping track of our square roots. So we have x minus 2 equals plus or minus 5. What I like to do at this point is write out what I call a double pathway. So we have two options. X minus 2 is positive 5, x minus 2 is negative 5. And let's follow each path to the end. Okay, so we can add 2 to both sides. And here we could also add 2 to both sides. And let's see what we get. X equals 7. And x equals negative 3. So those are our answers, x equals 7 or negative 3. All right, moving on. We have a couple special cases to look at, and then we'll wrap up this video. So you can probably tell that something unique is going to go on here. Let's subtract 5 from both sides first. Three x squared, 5's cancel, equals 0. Divide by 3. X squared equals 0. Okay, what happens when we square root 0? Are you allowed to? Yeah, you're allowed to. There's just one square root though. So x is just equal to 0. Okay, so this is an example of a quadratic equation that has one solution. Farther up, we saw a few where we had 2 solutions, right? So that's, again, another thing that's unique about, or special about quadratic equations. They have 2 solutions often. But here's one where we just have one solution. All right, let's do this next special case. And this is, again, going to open the door to a lot of work that we'll have to do down the road. It's going to show us something unique that can happen with quad functions. Let's divide by negative 2. Again, you don't want to multiply out the x minus 3. You don't want to square the x minus 3. That gets things a little more complicated than you need to. So we have the x minus 3 quantity squared equals negative 8. Are you seeing the issue here? Let's square root both sides. X minus 3 equals, what is the square root of negative 8? Let's find it. I get an error on my calculator. Okay, so we can't square root a negative. In Algebra 2, here's a little foreshadowing. In Algebra 2, we'll try to develop some methods where we can, sort of, square root negatives, but for now we can't, okay? So there are no solutions. There are no numbers that multiply by themselves to give a -8. So there are no solutions to this particular quadratic equation. All right, that's a good place to stop.